back over Hello World from yesterday, and then hopefully we're going to add some new stuff because there was a little error I noticed after I finished. So, main difference here is we're now working in a container that's running Alpine. This is still running on the Debian box from yesterday, but Alpine does function a little bit differently, hopefully not in any ways that you would notice for this sort of thing. Let's jump right to it. Open up Nano, and we'll call it hello world.c again. Just like last time, we have to include a little hashtag there. When I started learning programming, that was called the pound symbol, or the number sign. StandardIO.h, studio.h, whatever you want to call it. Main is going to return an int, and that is the thing I actually bungled last time. It's still going to take an integer called argc, and it's going to take char double star is a pointer to a character pointer, but that usually means it's an array of pointers to arrays. In this case, it's functioning as an array of strings in a higher level language. And that's going to still be argv. And the magic line we forgot, I believe, is return 0. Very important. Not for this program, but for others. And we're going to have our printf, our wacky nonsense, new line, and that should do it. Look at that. Alright. So that should be basically the same as yesterday, just with the little addition of the return line. Let's move on to program control. We're going to make a file called, how about if.c? Do an if statement there, huh? And you will be # include stdio.h quite a bit, because unless you got something else going on, that's your only way to access output. argv, look at that. 0. Alright, so if statement is quite simple. It's if. Bet y'all didn't see that one coming. And we need a condition of some kind. So let's go if argc, double equals for testing equality, single equals for assigning values. If you're not making that mistake, you're not writing C. And if argc is equal to 1, let's printf. Let's make this real easy on ourselves. argc equals 1, exclamation point. Exclamation points are funny. They're the funniest punctuation mark you could have. Included with if, there is this little else guy here, and this lets us do things if the statement is not true. We'll printf argc does not equal 1, exclamation point. Ooh. And to my eye, that should work.
That's why
I will have to get this rigged up to color the keywords, because that's going to get untenable in larger programs. And GCC, ANSI compliant. Ooh. Hey, hey, let's try running it. argc is not 1. Alright. Couldn't remember how this thing actually worked. That's actually a little irritating. Let's go back in here. See if it's 0. Should be 0. Well, that's fascinating. I wonder what it actually is. Okay. Let's throw another printf in at the beginning. argc equals %d is how you get an integer in there. I wasn't actually planning on covering that, but here we are. Almost forgot. Got to do that one yourself. And GCC, run it. Aha! It does say argc equals 1. Okay, I guess I missed that the first time through. Oh, let that be a lesson in paying attention to what your program's actually telling you. But I think that just about covers it for the if function. There's one more thing we could do. It's actually got... This is, to some degree, kind of obvious, but you can chain these together real nice. Does it let you do it as one word like that? argc equals 0. Equals 0, else if argc 1. Let's keep the exclamation points around because they're funny. And then you just have the else at the end. Else printf argc must be something else entirely. And we will fire that up. Ooh, else without a previous if. Oh, okay, it's got one of those going. Okay, so it doesn't actually have a separate else if command. You just chain them together like normal, and that should do the trick. Else without a previous if? What? Why is it angry about that? Oh, okay. You got the semicolon there. Yep, be careful with semicolons. It usually will tell you when you've bungled one, but not always. Expected semicolon. Okay. Just double verifying that it actually does not have separate else if. I thought it didn't, but you gotta check these things every once in a while. I'm a bit out of practice myself. That's why I'm making these. There we go. And argc is 1. So, that is that. I think we'll do switch case next. And we will #include all over again. Muscle memory is important, believe it or not. Int main. Int argc. Char double star. Argv. Return 0. I can't remember if I've covered this before, but the return 0 indicates a successful execution, and if you have some type of error, you return a different number. It's a very convenient way to do error checking as far as I'm concerned. Alright, switch case works a lot like if. The difference is the variable you're switching on has to be an integer. If can be anything you can get to evaluate to a true or false, which is an integer itself, but it ends up working a little different in the field. So let's see here. What is the actual syntax for a switch case statement? I don't use these a lot. I think switch argc like that. We have case : 0. Do you need braces? Golly, I cannot remember. Well, let's just give it a shot. These will be pretty simple. Print f. Boop-a-doop-boop-boo. Argc. Argc is 0. Exclamation point, yeah. Case statements, you do need a break. I think this is because when this gets compiled down into assembly and then assembled into machine code, the switch case statement is just a series of jumps. So if you don't have the break and you hit the first case, it'll execute all of them. It is something you will do eventually if you do this long enough. If you're not making errors, you're not writing code. Decided I am going to try it with the braces. Case 1. Printf. Argc is 1. Break. And then you have this handy dandy default. And default is just if nothing else got caught. Argc is something else. Very basic kind of programming tutorial here. I think I've seen people argue that you should put the break in there for formality's sake, but as far as I know, it shouldn't affect anything. So we'll leave it out just to save a couple of bytes. That's not what I want. There we go. Okay, will this compile? ANSI compliant. Oopsie. It's not PO, it's O. And what was the name of this? It was switch.c, I think. Error colon before printf. Expected. Alright, looks like we got some research to do. Good golly gosh. Error expected expression before colon. Okay, sure seems like we didn't do that correctly. Switch statement in C. Never be afraid to go ask the internet questions, folks. That's how programming gets done. Aha. Okay. I was sort of right on the syntax here. So according to Yon Internet, I use W3 schools. I guess I could go ahead and throw it up in the chat there. That would be URL. Flipping between different tabs is very annoying. Boop. There you go. Always cite your sources. That's how you make sure you're not committing plagiarism there. Although, rules for plagiarism get a little looser in programming, but you still don't want to get caught doing it. Alright, yeah, we don't need to GCC that. We'll get back in here, and it looks like what they actually want us to do is that. Which I think is pretty good for memory. I think default needed one too. Okay, how does that come out? Switch.c. Hey! argc is 1. Okay, so it looked like that worked. Switch statements, I already covered it. They can execute a bit faster than if trees if you're in a specific case where they make sense. Otherwise, you can burn a lot of cycles trying to, mangle something that would require an if tree into something a switch tree will accept. I would say it's a judgment call, but you can actually get timings on these things if you're not sure. Maybe that's something we should cover in a later video. Date tool's pretty handy. Alright. We covered if and switch. What were the last two? How about... Oh, the loops. Yes, of course. Oops. Toich isn't a command. For.c. For loops. I don't know why they always start with for loops. I think I've run into one programming book that introduces while loops first. They're way easier. And for is another one I'm going to bungle by not remembering the syntax. So, you're all ready to enjoy that. For.c. Alright. Once again, include standard.io.h. Haha. Int main. And int argc. Char double star argv. I should have that macroed. If you're using VS Code, you can do all kinds of crazy stuff like that. There was a nice feature in that would just stamp out a fairly routine boilerplate for HTML. Return 0. Now that I put that in, did we actually remember that in, let's see. Hey, we did. As long as we're double checking. Alright, we're rolling. Alright. Nano 4.c. Alright, what kind of for loop should we make? How about one that prints out something a little more fun than the same thing every time? This could be needlessly complicated, but needlessly complicated is what we're here for. Let's declare ourselves an integer, and we will call it... Let's have some good programming practices. It's very tempting when you're writing small programs, just call your integers like A, B, C. I should probably have commas, etc. And that's fine if you're writing a program or like a function, method, what have you, that's a couple lines long. But the moment you start to get longer than that, anyone that has to review your code is going to hate you if you do that. So, I think we will call this, and you can go too far in the other direction. I worked with a guy who, good programmer, don't want to cast shade on him for that, but he did have a tendency to name his variables and his functions an entire paragraph. You knew exactly what they did, unpleasant to type. It's all about balance. What if we just call this loop stop? Stoop! Loop stop. And you can actually initialize it on the same line. That's a topic we should probably go over. Initializing, declaring, defining. But we will initialize this to 5, seems like a good number, I think. Alright. If I remember correctly, ANSI compliant C does not like you to declare variables inside the loop header, so we have to do that outside. And by tradition, ancient concord one might call it, the first loop variable for a for loop, if you end up not needing more than one, is always going to be India. And you can actually initialize it out here like this, and then you can have your for header look like this. Oh, how does this work? It's the initialization step, and then I think it's the end test.
That's why I'm
So that would
president of
be
the Fashion Club.
I is less than loop stop. And then it's going to be the iterative step, which will be to increment I. We could have just put the 5 right here where we're using loop stop. That's what they call a magic number. In some cases it makes sense to do, but largely programming practices dictate you shouldn't. They want you to declare a constant, or I like to use, what do they call those? Macros definitions? I think it kind of depends. But you come up here, this is what they call the preprocessor, and you can do define. And since it is going to be a constant, it's not really a constant, it just works like one. I like to put it in all caps. Define loop stop 5. So now, if we were to come in here, we could use the capitalized version. And we could actually comment this out. One of the little buggeroonies about ANSI compliant C is that you cannot use the double slashes for single line comments. That does not exist. You will almost never see this empty declarative statement here. What they want you to do is you'll declare your variable here. I believe this declares and defines, and then you initialize it here with I equals 0. But you don't actually need to have anything in this slot if you don't want it. I do it all the time. It's very funny. It makes other people hate you. So, you know, use your discretion. And I think this is a little programming exercise you see a lot in intro to programming courses, and I think we're just going to try to hack it out right now. It's called a staircase. Got another for loop here. J is less than I. I suppose I should go back and explain this test here. I is less than loop stop and J is less than I. The loop continues if it is true, and it is top checked, so if it's false when you hit the loop statement, it won't execute at all. I don't believe there's a way around that for loops. There is a way around that for while loops, which we'll cover next. And J++, oopsie poopsie. Printf, very important. Oh, what do we want to printf? Let's use the pound sign. And then we want our new line in here. Oh, haha, we actually don't want a new line there. Ooh, almost missed that one. That would have looked weird. And we don't actually need one of those. Ah! Ignore all my typographical errors, please. Okay, another thing is if you don't have more than one line in your for loop, you don't actually need the braces. Whether you include them or not should depend on code readability. I think it's more readable to leave them out. If you are working for money and they tell you to put them in, you should probably put them in. Another thing you can do is you can actually run a for loop just to manipulate the variables in here, and it has no lines inside the loop. In that case, what you would do is you would just put a semicolon right there. It works with if statements too, but I have not found a use case for that. I believe this should work. Unless I've made some silly error somewhere, which is entirely possible. And ANSI compliant, output file, input file. Oh, it's mad about something. In function main. Aha, print f. Don't got any print f's running around. They sent me some. Print f. Where is our print f? Can't use the mouse in Nano, folks. We can. That should do her. Hey, look at that. It compiled. Does that mean it works? And there's our staircase. We can go back into it. And we can change loop stop. We can make that 3. Nope. Should probably compile it before we run it, right? And notice 3 was the stopping number, so we don't actually get to 3. That will cause a lot of what they call fence post errors in your code if you're new to this kind of thing. In simple cases, they're pretty easy to spot. I don't think I want to spend a lot of time on that now. If we keep doing this, they'll come up, and we'll address them then. Alrighty. Program control. I think C has a jump and a go to, but you're not supposed to use those, and it doesn't come up a lot. Oh, I know something. We can cover it in while loops. It works the same. Spelling things right is difficult and fun. You don't actually have to touch while.c before you nano it. Nano will figure it out. Another include. Studio.h. I should go back through and edit these videos so I pronounce that differently each time. That'd be fun. Char double star argv. I wonder if A-to-I is part of stdio. No, I think it's part of standard library. Okay, that's a fun one. We'll have to cover it later. Doing lots of stuff later. Start with the basics. Can you add 2 numbers together? Yes. A little Rick and Morty reference if one specific buddy is watching this. Alright. Always return. Yeah, you probably want to return 0. Alright, what are we going to do in this fun while loop? I'm trying to think of how we want to set up a while loop to really show what it can do. And I think unfortunately we're going to end up in a situation where we're basically going to have it mimic a for loop, which isn't an example I particularly like. But if we wanted to get much more advanced, we'd start having to dip into like reading user input and doing like string manipulation, I think. Things like that from standard lib and string.h. So I think we will just bite the bullet and use a while loop to make a for loop. But it should kind of demonstrate the differences. So we will do another definition. We'll call it loop stop again, and we'll make it 5 again. And while there isn't as much of a convention for this one. So I will specifically not use India. In this one, you obviously don't have the crazy syntax of the for loop. You have one statement, it's a true-false statement, and it will check it at the top of every loop. So we will start I at 0. And we won't get fancy with this one like we did with the for loop. Print f. Looped %d times. And we want our new line there, and we want our... Look at that. I didn't even keep track of my own variable names. Times looped. Yeah, we don't want to get all crazy like that. Okay. That should do the trick. ANSI compliance. And the output file is going to be while.o. And the input file will be while.c. Hey, it compiled. Will it run? Ooh, that's not good. So that was a very simple error. I forgot to update times looped. Look at that. Times looped plus plus makes it increment. There's another increment where you put it on this side. And that, as far as I'm aware, only changes the order of operations. And I've read through the Wikipedia page on the order of operations a million bajillion times, and I still don't entirely get it. This is supposed to be later in the order of operations, but the number of times you increment on its own line is about 99.9% of them, so it doesn't come up a lot. Generally, you want to put things on their own line as much as you can, but sometimes it really does just sit nicer on the page, or it makes more sense or something like that to cram a bunch of stuff into one line. It's a judgment call, unless of course you're being paid to write to a certain coding standard, in which case do that. Oh, right, there we go. Now it worked. So it loops until it hits loop stop, and then because it's top checked, it does not run the 5th time. Now, I hinted at this earlier, there is a version of the while loop that bottom checks. It's called a do while loop. And I think we'll get a little lazy here. And this does actually have a copy and paste function. Haha. It's actually a copy and paste function inside of Nano that you can use. I believe this one will take a semicolon. Okay. So this do while loop here, so named because do while, is almost identical to the while loop, but it bottom checks it instead. So if your condition is false, it will still execute, and then it will check at the bottom. Oh, I intended to go for break. Okay, yep, we'll get to that in a minute. And we'll recompile this, and it should let you see the difference. Huh, why did that... Oh, okay. Guess what we forgot to do? And by we, I mean I. Very important. Reset times looped. Why did it go to 5? Oh, it went to 5 because the do while loop wasn't false yet. Yeah. It'll always execute once. Compile again. And execute. There we go. Oopsie. So you can see it runs through the first while loop, behaves normally, and then now that I remember to reset it, it really does stop at 4, doesn't it? Well, I guess you got to see it both ways. Oh, okay, I suppose because when it's 5, it would still halt. But if you were to start it at some crazy number, like, let's say 15, we should see some notably different behavior out of this. Come on, execute. There we go. So the first while loop isn't executing at all. The second do while loop will execute once, check its condition, and then break. Speaking of break, that's the name of the next thing to show you. Break and continue. Continue does not come up a lot, at least not in my experience. Okay, so I think what we're going to do is we're going to comment all of this out. So we're just working with the first one. And we'll start it back at 0. Raise loop stop up to 5 will do the trick. And we can put a break statement in here. And break will just break out of the loop. Usually, you put it in some kind of if statement. So, go if, and this is a very trivial example, but it does kind of indicate how it works. Times looped 3. Maybe it would make more sense to do it with the do while loop. Oh well. I have a printf in here. Times looped is 3. Breaking. Compile and execute. And it gets up to times looped equals 3, and it triggers that, and you can see it has actually broken out of the loop, just like we wanted it to. This is actually a pretty good place to go over continue, I think. Oh, where's my nano line? There it is. Suppose I should probably watch my own stream. Times looped. We will continue. Times looped is 3. Continuing. So continue is similar to break, but it doesn't break you entirely out of the loop. It just skips the rest of the loop, which I believe would include incrementing the times looped. So this actually isn't a very good example. Oh, how can we fix this? Aha. Let's put another one in here. Again, these are kind of silly examples, but that's what you get when you're trying to introduce a concept. There we go. Okay. So, compile and execute. Times looped is 3. Continuing. So we got the alternate text there, I suppose is what's actually going on. And unless something crazy happens, I believe that'll cover it for the basics of program control. You folks, have a fine day.